All right, guys, now we're going to look at the second part of ionic bonding. And so what I want you to do is I want you to complete this worksheet, just the top portion of it, and I want you to come back and check your answers to make sure that you did it correctly. So pause the video now and make sure that that's done. All right, so what I'm going to do is I'm going to go over the answers real quick and just how to do this. So sodium, when we get our periodic table, we look at the number of protons just as a review. We find sodium is over here. It has 11 as its atomic number, so it has 11 protons. In a neutral atom, so when we're looking at the number of electrons, it will have 11 electrons. It's in the first group, so it has one valence electron, and the oxidation number is 1+, which means it's going to tend to lose one electron. I'll put the rest of the elements up here for you to check your answers. And so what we notice as we move through this, the metals are going to have positive ions that are formed, and your nonmetals are going to have negative ions, which means they are gaining electrons. All right, let's move down to the bottom portion. So the bottom portion is going to look almost exactly like our top portion did, where I want you to draw the model. I want you to balance the charges, and I want you to give me the name of each compound. And so the first thing we need to do, I want you to go through and I want you to tell me which one's a metal and which one's a non-metal. And to do that, you have to look at the periodic table. So let's start up here because we will use, well, we'll just start right here. All right, potassium. If I look at my periodic table, potassium is on the left side, so potassium is a metal. Fluorine is on the right side, so it's a non-metal. Magnesium is a metal. Iodine, when you look at your periodic table, it's over on the right side, so it's a non-metal. Go to the separate page. Sodium is on the left, so it's a metal. Oxygen is a non-metal. Sodium again is a metal. Chlorine's a non-metal. Calcium is a metal. Chlorine is a non-metal. This is a metal, and then chlorine is a non-metal. All right, so I'm going to work through all of these with you, and it's important that we know which ones are metals and which ones are non-metals, not only to determine which ones are gaining and losing, but which type of bonding is going to be happening. Because when we start talking about covalent bonding, two non-metals make a covalent bond. So I'm going to work the first few with you, and then I want you to work the rest on your own and then come back and check your answers for these. All right, so the first thing we're going to do is we are going to draw potassium. We're going to draw the Lewis dot structure. So K, potassium has one valence electron. And we've already done this one on our previous slide. Fluorine has 7. So what's going to happen is this is going to come over here. Okay, there's my Lewis dot structure. Now we're going to balance the charges. So you need to know your oxidation numbers. K has 1+ because it is in the first column. F has 1-, it's in the 17th, and that's the type of ion it forms. So these two are balanced. I have one positive, one negative. I write the formula, which is KF. And remember, I name it by saying my metal, which is potassium, and then my non-metal, and add "ide." So that's potassium fluoride. Moving on to the next one. Again, you want to look at your periodic table. Magnesium has 2 valence electrons. Iodine has 7. So magnesium has 2. 1, 2. Iodine has 7. I'm going to make them bond. So one of these comes here. Now this iodine is full, but this one's not full. So I can either add another magnesium, which I'm not going to do that because I'm not going to transfer from magnesium to magnesium. I'm going to add another iodine. And it starts off with 7 valence electrons. So this magnesium will come down here. Now they are both full, so that's your valence or your Lewis dot structure. Let's go and write the oxidation numbers. So I'm going to do Mg. It is located right here, which is 2 plus. Iodine is here, and it's 1 minus. Are those balanced? No, I have 2 positives and 1 negative. I add another I. Now I have 2 negatives, 2 positives. You write your formula. So this is balancing the charges. Write your formula. Metal first. There was only 1 metal. I'm not writing a 2. That's just the charge. And there were 2 I's. So I'll write I2. And then you name it. So we write the metal, magnesium. And then we do the nonmetal, iodine, but we drop the ending in at IDE. All right. Next one is sodium and oxygen. So sodium has 1 valence electron. Oxygen has 6. So the sodium is going to transfer here. That sodium is full, but is the oxygen full? No, it's not. I'm going to add another sodium. Now that oxygen is full. So there's my valence electrons. So Na1 plus, O2 minus. Look at your periodic table to get your oxidation numbers. Are these balanced? No, they are not. So balance them. Na1 plus. You cannot change oxidation numbers. You can add elements, but not add oxidation numbers. So now I have 2 positives, 1 negative, or 2 negatives. Write my formula. Na. How many Nas do I have? I have 1, 2. How many oxygens do you have? You just have 1. Na2O. And so when we name this, again, it's an ionic bond between a metal and a nonmetal. So you go sodium oxide. Remember, that 2 doesn't mean anything in terms of the name. When we start talking about covalent bonding, we will name them in a different manner. All right, let's go to the next one. Na plus. Cl has 7 valence electrons. This one is a simple one. Transfers it there. Okay. At this point in time, I want you to try to do the rest of the worksheet yourself. Pause the video and then come back and check all of your answers. Na1 plus, Cl1 minus. They're already balanced. So I have NaCl, which is sodium, my metal. Chloride. Take the nonmetal, drop the ending and add ide. Okay. Your next one, calcium, which has 2 valence electrons. Chlorine, which has 7. One of them will hop over here. It's not full, so I have to add another chlorine. And this chlorine will again have 7 valence electrons. All right, they're both in a place. Everything is full. This has 8, this has 8, this has 0 on that. Right now, it's actually gone down a shell. It still has electrons. It's just gone down a shell. So write your oxidation numbers. 2 plus, Cl1 minus. Are they balanced? No, they are not. To balance them, you have to add Cl1 minus. And I'm talking about balancing the charges. I have 2 Cl's. That's not balancing the element. I'm balancing the charges. So my formula is CaCl2. My name is calcium chloride. All right, and then your last one, aluminum, has 3 valence electrons. 1, 2, 3. Chlorine has 7. All right. Am I done? No, because these two need a home. Okay, I'm still not done. This one doesn't have a home. All right, so now I can actually look at this. Let's see. I have Al3 plus Cl1 minus. Balance your charges. Okay. Cl1 minus. Now I have 2 negatives, 3 positives. Now I have 3 negatives and 3 positives. All right, so all 3 of these things should match. I haven't said that yet, but all 3 of these things should match. So when I write my formula, Al, which means I have 1. I have 1 aluminum here, 1 aluminum here. And then how many chlorines do I have? Cl. I have 1, 2, 3 here, 1, 2, 3 here. If these 2 things don't match, then you've probably done something wrong, but you need to do them as their individual cells. And then my formula name be aluminum chloride. Okay, so that's the notes for now. Now, the next thing I need you to do is I need you to go back to your sheet, and I want you to complete the back of the notes that we looked at earlier. It looks like this, and it's a grid. It says create stable formulas for each set. Name the compounds that you create. So you can do it either way. You can either draw the Lewis dot structure, or you can do it by balancing the charges. The formula should go in each box, as well as some work if you're here, and then your chemical names go here. So if I did this one up here, I'll show you an example. So I have Ca2 plus Cl1 minus. That is not balanced. I have to add a Cl1 minus. And I'm going to do CaCl2. Then I'm going to go down here, and the name of this would be calcium chloride. And then you're going to go through and do the rest. So this one is going to be calcium and oxygen, calcium and nitrogen, calcium and sulfur. All right, if you have any questions, make sure that you